Music sounds like.
It's
David, you have to like.
Hello. Hello, humanoid. We are good. We're collectively good because we're one person.
Yes, like a team.
No, seriously, I will make you go back out that door walking.
Okay.
Okay.
I can't tell if she's joking.
Oh, we're
I
starting?
want to go back.
Yes? Okay.
On you.
Hi, we're the Aluminum Sharks, and we're a rookie team from Albemarle High School, where many of us are members of the MESA program, which is the Math, Engineering, and Science Academy.
alright, so I'm gonna tell you about our amazing robot here.
I thought Dave was gonna go first after Abby to tell us about
Yeah,
the
he is.
team.
We just
Yeah.
switched it.
Because it's
Talking
just a
about how our
walk
team's
when you
unique.
Just
straight
go,
from
just
that
go. Just walk.
to this. So
So did we decide not to do the names?
Names are
you
dorky.
make that decision.
No, we can
If
introduce
I can
ourselves.
interject, the way that we did it is we just introduced ourselves as we began talking.
Okay.
So I just like go, hi, I'm David, and I think our. I'm sorry. I think our team is unique because we all came from different, like, sort of social backgrounds, and so this sort of diversity of our team allowed us to fill in the positions in our team very well, naturally.
And then,
Who's next? And then with the robot.
The
The judges are gonna walk you through this.
yeah.
Yeah.
What is this new order that's been developed?
Yeah.
It's the exact same order that
Yeah.
David.
I was not told of this.
Yeah, I
Well,
forgot.
David, so we're not talking
Sorry,
about like
you're going to
our
go
actual
after
team.
David.
Okay.
Well,
All
they
right,
just said.
David,
they can
I'm just
continue
gonna
what I'm
suggest
saying.
one thing. Instead of saying I think, you gotta sell it. One unique thing about Aluminum Sharks is, and be confident, because it is unique, and be confident. So do it one more time.
Alright, so are we introducing ourselves?
Yeah, Abby's just finished, and you step up because you wanna be there.
Hi, I'm David, and one thing that's unique about our team is that we all come from sort of different social backgrounds, and this sort of diversity allows our team to fill in the different roles of the team sort of naturally,
To create this.
to create this wonderful machine.
To create
Arsenio.
Arsenio. And
I
then
thought you were
use
gonna talk about like how the different people had like different like talents that they were able to contribute to the team, which would like create like such like the diversity helped us because we had so many people interested in so
I
many different.
started out with something because like they don't know who we are, so be like our team we got today is like a group of people that came from like different backgrounds. So like like kind of like an introductory kind of maybe.
Because to just end with, and all our diverse talents helped us create Arsenio, our robot. So say that. All our diverse talents helped us create Arsenio, our robot. Just say that out loud. So that's Wesley's cue. And then Wesley's going to hear that and say, it's my turn to talk about Arsenio. So you
And
say
all
that.
all our diverse talents came together to create Arsenio.
Yeah.
Arsenio. So, this is our magnificent
Who
robot.
are you?
I am Wesley. Alright, so, as you can see here, what makes Arsenio unique is his arm extension. What we do
Ty actually did not put this thing together.
sorry. What we do is we have this geared up section attached to a motor, and this gives us our accuracy and power in order to lift this arm up and drop blocks in. We use this plexiglass scoop. We've tried different kinds, the metal, 3D printed. We found plexiglass works the best, and we use these servos to lift it up and down to contain the blocks. We bring the arm up, and instead of dropping the blocks in from the front, as most teams see as the obvious solution, we've thought outside the box, and we decided to drop our blocks behind the gas. This allows the arm to surface to do like a slide. Now, on the reverse side of the arm, you'll see our hanging extension, which we've tucked away nicely, I guess, as some would say. And we use this motor here to wind up the hook, which we use to grab onto the bar, while we use this winch to line out this bar, which raises up to attach.
I'm not gonna draw a
This is a complex way of thinking, but we find that it works relatively well. And we wanted to make it as compact as possible to allow for our other stuff.
Okay, great.
Which
You
one
have to
is
leave
it?
at 6. I'm gonna ask you to do this for me. I'm gonna ask you to let the drive team go drive. For the last 5 minutes, we're gonna make you 5 minutes late. Mr. Gardner says you're ready. Go drive, he leaves, and then we try it again, okay? I'm sorry, but all this has to be done. And you gotta drive while Wesley's here, Wesley's failing on it.
Right. They have to
Okay.
Good job, Wade.
Okay, so do you wanna go see it drive?
Yeah.
I mean, yeah.
Then you guys keep running through your presentation
I
since we
I
have.
feel like I should.
Go.
We'll have it here.
I'm gonna go like right next to
You up, Abby?
Okay. Yeah, that would be good.
Carl, you up, Abby?
Yeah.
Good, Wesley just spoke, go.
The one really unique thing about our team and our robot. Hi, I'm Abby, and one really unique thing about our team and our robot is how the robot has progressed over the course of the year. As a rookie team at the beginning of the year, we knew very little about robotics and how all the parts work together. So the first thing we did at the beginning of the year was we learned how to use the materials and through a process of building the bots, the starter robots that are in the Tetrix book kit. And then after that, we thought about the different things that we knew we wanted our robot to be able to do. And those things we knew were to be able to pick up blocks and to extend in some way. So for that, we decided to try to build some sample claws. And we used the Lego parts, which we were familiar with, to create prototypes for those claws. And then we also learned about door slides as a way of extending the robot. As you can see in these pictures, a member of the other Vertigo team, which is a partner team that goes to the same school as us and has meetings at the same time as our team, was giving us a demonstration on how those work. And then we combined those two ideas of a claw and a door slide to create a robot that had a claw, door slide, scoop that could extend as well as pick up the blocks. However, this was extremely difficult to use and to manipulate. So we went forward with a little bit of a different design, which was a 4-bar design where the tray would be able to lift up and down, some of those ideas that impacted our robot movement,
On the
with it pushes up underneath the blocks.
Sorry.
I'm done.
Hey, I'm Emmett, and I'm going to continue talking about the strength of our robot program today.
No, I mean, oh, yeah, it's okay, you didn't say it. It's alright.
While we're stopped, Abby, are you introducing the robot as well as a team?
Oh, should I say the robot's name?
Yeah, robot.
Because I was thinking about it, it's like I said, what's in there, what's the face.
Good idea, alright?
Okay.
Look, there's like do we just have like screws in all of these holes, so like every time we move it, it just flies out?
Well, no, it's because Ty didn't assemble it, so then I put it together, and then he like started taking out screws.
Go, Emmett.
Anyway, as Abby said before, we, as the team coming into robotics, had no idea about Tetrix or any computer-aided design, so we started out with designing just with our hands, and we formed our first basic robots using the Tetrix books, showing us how to. And as we became more skilled and experienced with the Tetrix parts, we went on to develop basic drive, which, as Walker said previously, we worked on what's too slow or too fast for our purposes, so we ended up with what we have today, which is just a simple motor connected directly to the wheel. And basically, this progression through learning gears really aided us into creating our final design that we have today, which is a 6-to-1 gear ratio, which helps us, 1 to 6. That helps us lift our arms slowly and accurately. And this is our second competition we've been to. And it is also our first time debuting our hanging design. As the last competition, we were unable to hang. And we realized simply getting there and going through the first year of the competition that hanging was going to be instrumental to any kind of success at all. So, seeing that, we managed to implement the hanging design into the robot we already had. So basically incorporating the hanging into the arm that was already into the robot. Now, Selena's going to talk about our trials of programming.
And how do we end? Who's doing?
I go after Selena, and I guess Reason would go after me with Outreach.
Okay. Do you want to talk a little bit about Greer?
That I gave him that information.
He's talking about.
I think you should talk about
We
it.
talked about.
He said very stubbornly that he didn't want me to do that, and I don't know. He wasn't actually stubborn. He just said, "Oh no, I can still do Outreach." I'm like, "Are you sure?" And he
you were
was
supposed to
like,
share it.
Yeah, it's on the schedule says you're sharing, so
Yeah, but
I don't
he knows
even
the
know what
stuff you did
schedule
and
you're
you
talking
do
about,
the
okay?
stuff you did.
Wesley, thank you. Did you get a chance to?
We tried to hang with
Hanging is not a good idea for tomorrow, would be my
Okay,
suggestion.
all
But
right.
the flag raiser is good, the
Awesome.
grabbing the blocks and dumping them is very good. Haven't had any time to test autonomous, I would suggest do that tomorrow morning.
Okay.
And test the flag raiser with the flag in the field, but
I
that
don't
looks
know
like
what
it's
we would have done without you today.
What?
I don't know what we would have done without you
Well,
today.
thank you.
Thank you.
I don't know what we would have done without any of you guys today.